leave.
They didn't give me a cane. So.
I wanted to talk to you about a study that Jane and I have done at the research ranch, looking at the effects of wildfires that have occurred out here in over the last decade on riparian trees. First of all, to thank a whole bunch of students. Well, Linda's in there too. It helped us get some great students. And to thank Linda and Roger for hosting this work at the ranch. As you all know, fire is a common and natural event in southwestern United States, and it has been relatively well studied in grasslands and shrub grassland savannas. What's relatively unstudied, I've learned, is what effect wildfires have on riparian systems that are attendant to these grasslands and savannas. This is important for a couple of reasons. Maybe the main one is that riparian ecosystems in this part of the world, as you all know, are widely recognized as centers of high biological diversity, and so in terms of managing fire and understanding how we should deal with it, this is really important. What few studies there have been on the effects of fire on riparian ecosystems have occurred in relatively low elevations, river valleys dominated by cottonwood. This isn't a low elevation river valley, but that is a cottonwood. There's been good work done, for example, over in the San Pedro by Julie Stromberg and her colleagues on the effects of fire in cottonwood and tamarisk systems. At higher elevations, in the more headwater areas in this part of the world, the riparian woodlands become more diverse. There's a greater variety of things, so that on the research ranch here, for example, there are populations of cottonwood, Arizona walnut, thanks to Linda for these great slides, by the way, velvet ash, desert willow, and my personal favorite, the sycamore. There also are true willows, although they happen to be sufficiently rare on the research ranch that I'm not going to be able to tell you anything about how they have responded to fires. In 2004 and again in 2003, 2004, and again more recently, we were able to measure the condition of 250 individual riparian trees on the research ranch here, belonging to those 5 different species in 4 different canyons or portions of canyons burned by one or both of 2 different wildfires. The 2002 Ryan wildfire that burned the entire property except for Lyle Canyon, and the 2009 Canelo fire that burned Lyle Canyon, and a repeat fire in the upper portion of O'Donnell Canyon. This study is a result of a natural experiment, so of course it's a mess, and we had to deal with the circumstances of A, we didn't get there until the first fire had already occurred, and secondly, then the second fire came along and did some things some places and not others. But the essence of it is this, and this is a table that you don't have to memorize, I promise, but I just wanted to show you the data. It's species here, in the different canyons with their individual fire histories here, adding up to the total of 250 trees. So Post Canyon and Lower O'Donnell Canyon burned only in the Ryan fire, Lyle Canyon burned only in the Canelo fire, and Upper O'Donnell Canyon in both years. For each of these trees, one other thing I want to make clear also, we didn't get on the ground and start to look at the condition of these 259 tagged trees until 2003, when they'd already burned. But in fact, the skeletons of the trees, for those that were severely damaged by the fire, the skeletons were sufficiently intact when we went out in that first field season that we could see what the surviving tree looked like compared to what it had more or less been geometrically prior to the fire. And that's an important consideration. For each of those individual trees in each of the 2 sampling periods, 2003-4 or 2012-13, if we put each tree in a category. The first really simple category is stone cold dead. That was the easy one. This is an ash tree, right? It's actually right out there that was killed by the Ryan fire. A very common pattern among the response pattern that we saw is represented by this sycamore tree, where the pre-fire stump or stem appears to be totally dead, but there's a lot of ground level resprouting going on. All of these riparian species have the ability to some degree to resprout from the ground. So that was a category. And then it ranged upwards from there all the way up through to an example of this cottonwood up in O'Donnell Canyon. The whole area is burned. That tree is absolutely unscathed. Now I want to make it clear here why. I mean, we didn't just pick trees to study, okay, what happens when you set a cottonwood tree on fire? We said, what happens to a whole population of riparian trees when a fire comes through? Some of them get spared. In this particular case, probably because of where it was. There wasn't a lot of fuel around the base. We put each tree in one of 4 categories, sort of as a way of quantifying this. The stone cold dead category, ground level resprouts only, some canopy survival, or some canopy survival plus resprouts, and then trees that, as far as we could determine, were at least 90% of what they had been prior to the fire, so pretty close to unscathed. And then we averaged these for the different species in where each tree had suffered 1 fire, and then at the end by whether they suffered 1 or 2, depending on where they were. This graph is a graph of the mean condition ranks of those trees by species. The open bars after they suffered 1 fire, either the Ryan fire in 2002 or over in Wild Canyon, the Pinello fire. The pattern at the end of the study, the black bars as opposed to the 1 fire, is essentially the same, a little more damage as a result of the second fire, but the differences among the species are consistent. Ash trees and sycamore trees had the highest survival in terms of overall condition. Cottonwood and desert willows the least, and walnut intermediate, and that was consistent. But you'll notice that even among the trees that did pretty well, for example, at the end of the study, the average condition rank of a sycamore was 2 out of a possible 4. So even the trees that did reasonably well took a hit. This summarizes data for sort of the percentage of each of the species of trees that were really severely damaged. Either they were killed outright or they survived only as ground level resprouts. And you can see 32% of ash, 57% of cottonwood, 64% of desert willow, 48 and 25. A high percentage of each species were either dead or only there as a resprout. There were important differences among the species in these categories. Good example, desert willow and cottonwood were the 2 hardest hit. Desert willows, relatively little complete mortality, but a whole lot of trees that were simply resprouts. The reverse is the case with cottonwood. Cottonwoods were the least likely of these 5 species to show any resprouting. But you can see, again, a substantial amount of damage, particularly among the cottonwoods and desert willows. Sycamores did the best overall, and in fact we found no totally dead sycamores after 1 fire. There was 1 sycamore over in Turkey Creek that got burned twice that was dead out of the whole sample. So I guess the bottom line about this is a lot of damage to these trees from these 2 wildfires. The Ryan fire of 2002 was unusually intense, unusually hot for a whole bunch of, it was sort of a perfect storm kind of a fire. Real productive summer preceding a real dry winter, 60-mile-an-hour winds, it was awful. The Pinello fire much less severe. One other mystery that I'm going to get around to something that even people would like to spend all their time in the water might find interesting. A puzzle that requires some further explanation is this, and it takes a while to get your head around this, but read what I got up here. Among the trees that were burned in the 2002 fires, those that were destined to burn in 2009 were in better condition after the first fire than the other ones. Okay? The trees that were due to be burned twice were happier after the first fire than the trees that weren't due to be burned twice, and I'm pretty sure they didn't know it. But I think, and now okay, why? These are those data. These are data from 2003, 2004, and the average condition rate of trees that were only burned in 2002 versus those that were going to be burned in 2009. And by the 2012-2013 sampling period, it had evened out. In other words, it took these trees 2 fires to suffer the same amount of damage as those trees. Well, what was that about? What that was about was the only place on the research ranch that burned in both of those fires was the upper end of O'Donnell Canyon. And the upper end of O'Donnell Canyon is the only place on this property that is perennially wet. I told you, if the people like to have their feet wet, we'd get around to this. I think, and some of the work that Julie's done over in on the San Pedro showed the same thing, that in areas with a high water table, fire is less damaging to these riparian trees than in areas with low water table. It's not that Upper O'Donnell is not a big water barrier, as you can see from this slide, but I think these trees literally had their feet wet, and it resulted in them being less damaged by the wildfire than those that did not have their feet. These are ash trees right along. You can see how, I mean, it was a hot fire, but these trees survived really well. However, to sum this up, by the conclusion of our study, after either 1 or 2 fires, over a quarter of the 250 trees were completely dead. Another 32% survived only as ground level resprouts, so that less than half the trees really had any substantial amount of their pre-burn canopy left. Given the widely recognized biodiversity value of these mature riparian woodlands, this is a significant problem. Management implications and recommendations are, if we want to sustain these things, we got to learn some things about how to manage fire in these systems, if what's going on in the research range is at all representative. Mitigation strategies, tough. Mechanical thinning is one way. You got to reduce fuels. It's expensive. Livestock grazing, you can certainly reduce fine fuels, but I don't need to tell any of you about the potential impacts of livestock grazing on riparian systems. Prescription burning is a topic that has received some attention. There's a recent literature review looking at the effects of prescribed burning on riparian woodlands in the West. And most of the studies, most of the work that's been done suggests that the prescriptions had relatively little impact in sort of fireproofing these systems, because I think perfectly understandably there's a real fear of getting out of prescription, of damaging these woodlands while you're trying to fireproof them. So that most of the time when prescription burning has been done in riparian systems, at least that's reviewed in this literature, it's been so benign that it didn't reduce fuels very much. But nevertheless, I think this is an area that needs a lot more attention. I want to thank Jane, who's out there to help with this project, and thank you for your attention.
Time for a couple questions.
What? Yes.
So just a question or a thought to add to your mitigation strategies. Wouldn't another potential mitigation strategy be keeping more water?
Absolutely. I thought of that last night, and I forgot to make you right. Absolutely, yeah. There's pretty good evidence that if these trees are going to have happy feet, they're going to be better off. Yes.
Yeah, after a fire, does scarification have any influence on a subsequent fire? In other words, does it protect the tree in any way, or does it make it more susceptible?
Good question, and I'm not sure. The way our study was set up, I don't think I can really answer that. It's interesting though. I mentioned that our hypothesis is that the trees in Upper O'Donnell Canyon were better prepared for the Ryan Ryan fire because of the higher water table. It also turns out, and Linda here can confirm this, that that's also an area with a previous fire history more than elsewhere on the ranch, and it's possible that fires that we didn't study prior to 2002 thinned things out, killed some weakened trees, so that in fact the upper O'Donnell trees that went into the Ryan fire had sort of been battle scarred and were, you know.
Sort of a common thing that you often hear is, well, walnut bark is so tough, but it really doesn't seem to matter. You
Well,
know.
redwoods like that.
Yeah.
Yes, ma'am.
I have some observations up on at Canelo Hills Preserve. The 2002 Ryan fire, I was working there quite a lot at the time, and there were three really big cottonwoods up by the house, and the friends of Canelo, who were taking care of the house at the time, had done a really good job of clearing all around the house and the barn and all that, and so it all survived. Those three really tall old cottonwoods died because there was all this stuff on the ground all around them. Their limbs had been falling off and all this litter all over them. I think that's why they died, you know, and they hadn't thought to clear out, you know, those trees, which were really kind of a landscape feature, you know, at the house. Then down on the creek, a fire had come down the creek earlier from a neighbor clearing out his cattails at the pond, and that fire got away from him and went down the creek, and it killed some cottonwood trees, not very many, and then the Ryan fire came through and burnt the dead ones and killed some more. And so I was thinking about the fire taking out some of that undergrowth, so that when the next fire came through, maybe there was less undergrowth in O'Donnell. I was wondering if you went up that far onto the Nature Conservancy.
I didn't. That would be a very good thing to look at. One of the papers that Julie Stromberg wrote, there's evidence that controlled flow cottonwood gallery forests are more damaged by fire than free-flowing cottonwood gallery forests, and her hypothesis on that was that the flooding actually washed some of the debris away, so that you're clearing that those places where there's no flooding, there's more junk on the ground, like cottonwoods around your headquarters up there. I don't know how we're doing time-wise.
Okay. I have one question for you. So on San Pedro, beyond, and Ben's not here to ask this question, so I'll ask it. They're putting together a riparian management plan, and one of the things is they may do some prescription fire, but it's full suppression is their plan.
Yeah.
What's your take on that sort of management plan?
Well, at least in the near term, if you can't somehow get a handle on the fuels, you know, my advice to Linda would be, you see a fire going toward Riparian, keep it the heck out of there if it's possible. It's just, there's an historic aspect to this that's intriguing, which is some people have suggested that these big, mature riparian woodlands are an artifact of fire suppression, and that in fact maybe they oughtn't to have, you know, they oughtn't to be that wooded. And there's some pollen evidence to that effect. I think Minkley did a paper about that. But given the recognized biodiversity value of these things, I wouldn't be the one to say, okay, it doesn't belong there, torture it. I don't.
I'm working with Ben on that management plan, and it is full suppression. It's policy. It's not up for discussion.
I understand. That's why I asked the question. I can ask it.
On top of that, you expect natural fire starts and also human fire starts. I mean, it's kind of ex-urban out there. There's a lot of homes. So you expect fire starts. We have fire breaks in the riparian area every so often, because we did recognize with the loss of younger trees through competition and limb fall off the old trees, there's a huge fuel load. And we could lose several miles in one fire very easily. It'd be out of control.
One of the recommendations that reviewer made on the manuscript that I have related to this was something called put in fuel breaks. You know, strategically place fuel breaks that you can't afford to take all the fuels out, but you might be able to get them in places so that you don't lose the whole thing in one day.
Right. We might lose half a mile or a mile in one fire, but we won't lose several miles.
Right.
Yeah, and with the way we're doing it is we picked areas that are already naturally canopy thin. So we didn't have to cut too many trees. But we will have to thin young trees as they come in on those barren areas because those are perfect seed beds and they are going to have to be thin. Yeah.
Okay, yeah, first one we're out of time, so.